Michael Landis here with Forsyth Technical Community College. Today we're going to look at a couple of electrical diagnostic procedures to find shorts in a circuit. A shorted circuit that is blowing a fuse is something that happens due to animals chewing on wires misrouted incorrectly, something being installed incorrectly. It happens, and it can be difficult to find. There's a couple of procedures that will help you narrow down the problem. We're going to take a look at two of them today that are fairly simple, doesn't require any special tools. You can buy these parts at your local parts store. You can get them at most any general department store. It's fairly simple. So let's take a look at how this is going to work, how we're going to trace out this short in the circuit and see what happens. And we're going to take a look at the parts that you're going to go get and make a couple of very useful tools for yourself. Okay, so to begin with, if you're doing electrical work, you're probably going to have jumper cables around. A lot of technicians make their own jumper cables. It's just a wire. Get you some alligator clips. You can pick these up fairly cheap and put on the ends of them. That way you can connect it to two circuits and you can do a lot of useful things with them. One of the things you got to be careful with jumper wires is if you jump power to something, you're taking the fuse out of the circuit. You don't want to leave anything unprotected. In this case, this vehicle that we're going to look at today has a short in it for the brake lights. If I didn't have something to protect the circuit, it would melt the wires. So what I did is I went down to my parts store and I got a fuse holder. Then I got a fuse or a circuit breaker, and the trick with these fuse holders, because the fuse is designed to fit all the way down inside of them, is you have to get a circuit breaker that has the extra legs on it. These are extra long legs. You can bend the tabs and break them off as needed for what you need to do. I want both of them on there because, as you can see, it just barely fits into my fuse holder. But those longer legs on there allows it to fit down in there. Now, this is a circuit breaker. It is a 10 amp circuit breaker. So, being that it's 10 amps, I can use this for most circuits. And 20 amp circuit, 30 amp circuit, 10 amp circuit, 15 amp circuit. I don't want to use it on a 5 amp circuit or a 7.5 amp circuit or something smaller, because the wires may not be big enough to handle 10 amps and it could damage the wires fairly quickly. Now, all I did was I put two alligator clips on the end of it. We should always use a fuse in the circuit when we're using a jumper wire. If you're dealing with something bigger, you're trying to run an electric motor or something, then feel free to take this out and put a 20 amp or a 30 amp in there, but make sure you don't overload the circuit that you're working on. This should be same size or smaller than whatever the fuse circuit is that you're working on, to make sure you don't damage the wires unnecessarily. So, fairly simple. The reason I like to use this is it resets itself. If I blow the fuse, I don't have to replace the fuse. I see a lot of good technicians go to the parts department and trying to find a short, they'll run through 3 or 4 different fuses before they really get too far into diagnosing it. But there's no reason to blow a handful of fuses when you can do this. Now, the other tool you can pick up at most places carry car parts is just a standard headlight bulb. I like using this one. I do have a couple of them. This one is just a standard round incandescent light bulb in it. It's not even a halogen, and it pulls about 2 amps of current. So not a whole lot of current, but it is enough that I can put a load on a circuit. And I put wires back here. I taped them up just in case I ever need to take it apart, but I left the very edges of it right here so I can do some testing with it. That way, if I want to do a voltage drop test across this bulb, if I install this into a circuit and my bulb is dim, I can go right here and check power and ground to the bulb, and I can do a voltage drop. And if I'm applying 12 volts to the bulb, but I only have a 6-volt drop across here, then there's some other load in the circuit. And you'll probably see that here in just a little bit once we fix our circuit. Now, I did the same thing. I just soldered 2 wires onto it, put 2 alligator clips on the end of it. Makes it fairly simple. So to give you an idea of what we're going to do is I'm going to take my fusible link and I'm going to hook it up to my positive battery terminal. I'm going to hook this up to one of the terminals to my light bulb. And I'm going to hook the other end up to the ground. And I'm going to hook it up away from the battery just to make sure that we don't get any sparks. We don't want any sparks because if there's any gassing at the battery, it could cause a problem. Now you can see the light bulb is lit. So I do have current flow through the light bulb. So my light bulb works. So there's a couple of procedures. One of them is called a split half method. Basically what that says is I'm going to go halfway through the circuit, unplug it, then let's try the circuit again. Well, if I'm blowing a fuse, every time I'm plugging a fuse in. So what I'm going to do is instead of doing that, having that happen, I'm going to hook a light bulb in. And in this case, my light bulb, let's take another wire. Nope, that one's not hooked up to anything right now. And my light bulb becomes the load in the circuit. It only pulls 2 amps, so I can use this on a 5 amp circuit, no problem. That's why I get the smaller one and I don't get the big halogen one. If you get one of the bigger halogen bulbs, then they're going to pull about 10 amps. They're also going to get a lot hotter. And you'll see sometimes I have this inside of the car and I may not want that heat there. These don't get that warm. Just enough that you can tell there's some heat there. So what the split half method does is it says, let's break it in 2. Let's disconnect part of the circuit and then try it again and see if it works. So we're going to take a look at that. But I have another demonstration here for you with another tool that's actually going to utilize this circuit breaker that I put in here. Okay, another way that we can diagnose a circuit is by applying power to it, let current flow, let it blow a circuit breaker, and while current is flowing for that split little second that it's going to take to blow the circuit breaker, we can actually trace it out using a couple of kind of neat tools that are inexpensive. You may already have them in your garage. I have my jumper wire hooked up to battery power for my demonstration. I have my fusible link with a 10 amp circuit breaker in it. It comes down and it is hooked here to our light, and our light has a ground. I'm using this to show you that the light bulb, to show you the power is going on and off. Now I'm going to take the other end of this jumper wire right here and I'm going to hook it to ground. So Ohm's law tells us electricity will take the shortest path of least resistance. So since the wire is going to have less resistance than the light bulb, it's going to end up blowing the circuit breaker and the light bulb's going to go out. So our light bulb went out. Our circuit breaker, you can hear it click. Our light bulb is not coming on. So there's some neat tools. Now, you can hear the clicking in this circuit breaker. There is a tool that you can buy from tool supply houses, from tool trucks. It's called a short finder. It's a little round tube, a little bit bigger than about twice the size round of a Lifesaver pack, but about that long, has a wire coming out each end. All it is a tube that has this circuit breaker in it. One thing I don't like about those, one of them that I took apart, and I won't go into brand names, inside I found a 30 amp circuit breaker. Well, what if my circuit was only a 10 amp circuit? That's enough to damage my circuit, so I don't want to use it. But they come with this gauge, like what you will see here. It's got a needle in it, and the needle will fluctuate to tell me that there's current flowing in the circuit. So if I put this over the wire right now, every time that circuit breaker clicks, you can see the needle take off, because the needle knows that current is flowing. It picks up on the magnetic lines of flux. And same thing if I go over here to the beginning, there goes my needle. But if I go over here to the light bulb circuit, almost nothing. Tiny little bit, but not enough flows through this part of the circuit, so my problem isn't there. So I will just, the idea is I will put this over the wiring harness and I can trace it to wherever it goes. Well, you get this with that short circuit tester, and there is a way around it, and you probably already have one. A compass. Compass, if you've never used one, works off of magnetic fields. It picks up magnetic north from the earth, and the needle points that direction. So if I just put this over the wire, watch what happens to the needle when current flows. See the needle jump? And so now I can just trace it out, follow it across my wire, and you can hear the click, and I can keep following it until I find the short circuit. So as long as I have it over a wire that current is flowing through to the short, that needle is going to jump just as you saw. And I can put it over top of it, I can put it under it. Either way it works. The only downfall with this is it does not seem to work as well when you stand it up, because these are designed to float. It does work, but it doesn't work as well as an angle as this one does. This one's standing straight up and down, and it doesn't have to, the needle doesn't have to float, and so you see it take off. So then I can just go through my circuit, and when I find the problem and I remove the ground, then everything will go back to working normally again. As soon as it clicks, light goes on. So those are some simple ways to do it. Now let's look at a problem that's not real life. I have created it, but it's a problem that could come up, and use these tools to diagnose it. What I did is, this vehicle is blowing the fuse for the brakes. So I went up underneath here and I pulled the fuse out, and I put a pin in for the brake lights so I could hook my wire to my light bulb onto there. Now I went out here to the battery and I used my circuit protection device, my circuit breaker, hooked a jumper wire to the positive battery terminal to a jumper wire that I can go not quite all the way around the car, but close to it, and I'm going to hook it into the lights, and you'll see the light comes on. So that means I have a ground. Problem with this car, if I put a fuse in there right now, it blows the fuse. But what I'm doing, notice the light, it's fairly bright, and we'll see it dim down once we fix this problem. The light is my only load in here. I could go to the back of it and do a voltage drop across the light bulb, and I would get about 12.5 volts battery voltage. So now what we're going to do is take a look at our wiring diagram and see what's going on. So here's our wiring diagram, and here's our fuse that's blowing. We've got a switch here, and I do have a pedal depressor in right now holding the switch closed. If I release the switch, then the fuse doesn't blow, but if I apply the switch, the fuse blows. So with that in mind, I know it's not between the fuse and the switch, it's somewhere after the switch. And you can see here's the right rear lamp assembly, center high mounted stoplight, the left stoplight, trailer tow relay, that could be a problem, the electric brake for trailer towing, and there's also a brake lamp switch output that goes to the controller. So any of these wires could be there, and there's not a common disconnect. I could go to this connector and I would disconnect center high mounted, the left rear, and the trailer tow, and I would have to detrim this. It's probably easier in this case to get to the lamp housings first, so let's try that. I've kind of done the quick disconnect for you. So I've already taken my housings apart, and I'm going to disconnect the left one, and I still have a light bulb burning. So that means it's not in this housing. So let's go to the right one. We'll take the right one off, disconnect it, just in case it's in this circuit board, and we'll move it out of the way, and let's see if we still have a bright light. Here we still have a bright light. So I could pull this down to get to the wiring harness here, but on this vehicle it's just as easy to go ahead and remove the headliner. There is a connector here that this hooks up to. A little bit of a pain to unplug it, but I'm only interested in one wire, and that's the one that goes over here to the third brake light. So if I disconnect it, so now I've disconnected the third brake light, and let's see what happens. Our light has gone out. Now our light's no longer lit after I disconnected the third brake light. So just to be sure, let's try plugging it back in. So if I plug it back in, our light comes back on. So if I remove the third brake lamp from here, and it's just a little short harness, our ground goes away, so our short must be in the third brake light. And you can see I have removed the third brake light, and that is actually our short. So I'm going to take the ground away and show you what the light bulb will look like. It'll be different. Okay, I wanted to show you the voltage drop test if you're not sure how bright your light bulb is. You can see on this one how bright the bulb is, and my battery is a little bit weak, But the way I've got it hooked up, this light bulb is using up 11.3 volts. And I probably only have about 12 at the battery right now because I've been playing with this car for a little bit. So if I go back here, my brake light is not on. My other brake light is not on. And I have a short. If I remove the short, my brake light now is on. This brake light has come unplugged. Or did my pedal come loose? Nope, my pedal didn't come loose. So I've removed the short, and what I'm going to find is when I go back up here, now my bulb is not quite as bright as it was a minute ago, and if you look, it's only using up 8 volts. It's using up 8 volts, so there's 4 volts going back to the rest of the car. So we have found our problem. Now our light bulb is no longer using the maximum voltage. This light is dim. My third brake light is dim, but it is barely glowing. I don't think you can quite see it because we've got an extra load in here. So that's one way to diagnose the circuit. That's how you can diagnose it using a light bulb instead of putting your fuse in. Now, when I get done, I know that everything's going to work correctly and I'm not going to blow a fuse. So now I could actually bypass my fuse or my light bulb and hook this back up. And now, as you can see, brake lights are on, that light's on, and if you can see that one, it's on also. So that's one way to diagnose a short, by disconnecting pieces. I didn't put a fuse in there, I put a light bulb in there. That way, as long as the light bulb was on, it was using up current, so I wasn't damaging anything. And with this particular light bulb, I know it only pulls 2 amps, so I'm not going to overload the circuit. Now let's take a look at another way to do this, because with everything there's more than one way to do it. Okay, I've made one change to the way I'm doing it just for ease of making this video. I've brought my circuit breaker in here, hooked up to the output of the fuse, and my jumper wire is going around to the battery of the car. So it's supplying power, it's going out to the battery of the car. I have put my short back in and you can hear the circuit breaker clicking. Now if I use this, you can see the needle click. When you hear that click, you can see the circuit breaker clicking on and off. Let's current flow for a second, then it goes back. Now, if I have an idea of where the wiring harness runs, I can kind of chase this. If I want to make sure it's running from the front back to here, what I did is I pulled this loose because the wiring harness runs right up underneath of here. And now, without any intrusion into the wire, see the needle clicking when that circuit breaker clicks. That means there's current flowing through the wire up to that point. So it means my problem is after this point in the wiring harness. So now if I go back here, and if I had just gotten this car, all the trim panels are in place. I really don't want to take them loose, but I know that third brake light comes into play. I can put it right here without even taking the gate loose and see it clicking. So that would tell me I need to pull this lift gate off, and then I could find my problem, which of course, as we know, is a shorted third brake light assembly. Now I can use the cheaper version, and I'm all for using tools that you don't have to buy, that you may already have. So if you've been camping or Boy Scout in the military, you probably have one of these. So if I put this over the wire, you can see the needle move when it clicks back and forth. Problem with this is it works better if it's level. The more level you put it, the better it is. Not quite as dramatic, and you got to make sure that the way you have it sitting, it's better to have it crossing the wiring harness. Now I can do the same thing here, put it over the harness, and you can see the needle move back and forth. Same thing if I go back here. But what I'm going to do is try to keep it closer to level. See the needle move? Click on, needle moved. Click off, needle moved back. So both of these would work fairly well. And that didn't take but a minute to do. Of course, I knew where it was, but I also know, general rule of thumb, you have a good idea of how a car that you've worked on before is wired. And in this case, the wiring harness comes down the passenger side, underneath the kick panel, and behind here to the back of the car. So with just a couple quick checks in a circuit breaker, I could narrow that down to I need to pull the liftgate panel off and inspect that third brake light, and that's where my problem lies. So there's a couple different ways you can check it. Light bulbs work great. You can use that to tell if there's a load in the circuit to keep from blowing the bulb. Circuit breaker works even better in my opinion, because I can trace out the actual wire. As long as I can get to the wire and harness, I can trace out wherever it's going to. Pick whichever one works for you, whichever one you like. I generally keep both of them in there because, as I said, the light bulb, sometimes you get a circuit that just won't quite carry the current, has some resistance to it. Maybe there's a connector in the body somewhere that has some resistance to it, and let's say you've got a fuel pump that's running slow. Well, if my fuel pump is getting power and ground when I unplug it, could be there's resistance in the circuit. So if I unplug the circuit, put a light bulb in, I can do a voltage drop across it and find out if there's another load in the circuit keeping it running. So a couple of ways you can check a short circuit. A little bit later, I'm going to round up some more homemade tools and we'll go over finding an open. Thank you very much. Land us out.